So we are back with a new video. So as we discussed in our previous video, an example of joint probability distribution in which we had solved all the five conditions, that is your expectations, your covariance, your correlation, and expectation of x, expectation of x and y, and how to find your distribution of x table, y table, everything we have discussed very precisely. Okay. Also, I had told you in my previous video that we shall be discussing about a problem such that in which they'll itself give the question, that they'll give the distribution table of x and distribution table of y and ask us to find the distribution table of x and y. So the same problem today we are going to discuss. Okay, so now let's get started. So see, they have given, suppose x and y are independent random variables, okay, with the following respective distribution. That means following this distribution tables of, that is x table, this is y table. Find the joint distribution of x and y. That means we have to find the bigger box in which in previous video, that is previous example, they had given in question. So here it's reverse, we have to find that box only here. Okay, that means, and after that also verify that covariance of x comma y is equal to 0. Okay, so I feel you understood. They have given distribution of x and y and asked us to find the distribution table, joint distribution table of x and y. Simple. Okay, how it is found, I'll say you. So first the question is, why we need to find the joint distribution of x and y? We can clearly get mu x here by using this mu of y here. Why we need? Because they have asked us to verify that covariance of x comma y is 0. So now, what is the formula for covariance of x comma y? See, covariance of x comma y is nothing but your e of xy minus mu x into mu y. So your mu x and mu y are nothing but e of x and e of y. Yes, is it? So it can be easily found using your distribution table of x and distribution table of y. But in order to find e of xy, I must and should require the joint probability distribution table. That means joint distribution table of x and y. And so that I can substitute here, I can find using that table, I can find e of xy, substitute in this value and find my covariance of x comma y and verify whether it will be 0 or no. Okay, so we shall do it. Okay, so now the question arises, how I can find using these two? Okay, so we shall discuss. Okay, so now we have x and y. So now first we'll find the joint probability table of x and y. ठीक है, x and y. ठीक है. Now nothing but this is your x, this is your y. So now just now put it here, x bar y. ठीक है. Now that is nothing but this whole row implies to your y values and this whole column implies to your x values. Okay, in particular, if I want to say this whole row implies your yi values, what is your yi values? Nothing but -2, 5, 8. Clear? So we shall put it down, -2, okay, 5, okay, and 8. Clear? Okay, so and this whole column implies to your xi values. Nothing, what is your xi values in your given question? 1, 2, 1, 2. ठीक है. Now the question arises, where I have to use these f of xy xi values and g of yj values? No, nothing but, so see, now if when my xi value was 1, my f of xi value was 0.7. nothing but, so see, if my, see, xi value is 1, so if I consider here f of xi, and okay, let it be, oh, f of xi, okay, leave it. If my xi value is 1, then what will be my f of xy value, xi value 0.7. In row of 1, you put it here, 0.7. And similarly, when my xi value was 2, my f of xi value was 0.3. That means in 2 row, when xi value is 2, f of xi value will be 0.3. And here you note that 0. If you add these two values, 0.7 plus 0.3 is nothing but 1. Why? Because it is very basic rule in probability. I have said in very first video of probability distribution that any probability, any probability, if we go and add them, then it won't exceed my 1. Okay, so this is how 0.7, 0.3 will be always equal to 1. Okay, so now similarly we can use these values here by using g of yj, placing here g of yj. I'll use it here, nothing but when my yj value is -2, my g of yj value will be 0.3. okay, similarly when my yj value is 5, g of yj value will be 0.5, 5 here 0.5, similarly 8, 0.2, 8, 0.2. And even if we add these three values, 0.3 plus 0.5, 0.8 plus 0.2, that is 1. See, you have got the value, it won't exceed 1. So this is how basic idea. Now how I need to fill these 6 boxes? What is the procedure? So for now we shall assume it as a with using a variable j. How? So nothing but, this is my first row, is it? Yes, this is my first row, right? This is first row, this is second row, and this is first column, second column, third column. Okay, how you were representing in your matrices, same way. This is your first row, that means 1, j1, and this is your first column, that means still 1, or another one, j1, 1. Okay, again j. This is your first row, second column, that means first row, second column, again first row, third column, and now row has been changed, second row, j2, j2, and this is your first column. This is second row and first column, second row, first column, second row, second column, second row, third column. And don't get confused that in every case these values won't be 1 and 2. It might be some 3 or 4, 5 and 6, but it is always called as your first row and second row only. In order to just understand, and don't get confused that here we have 1, that's why I have taken here 1 only. Okay, don't get confused. Okay, so now it is clear. Now how to find all these j values? Nothing but, so now I will consider this j11. Okay, j11. Okay, j11 is nothing but, so in which column it is present? In which column it is present? 0.3. I need to use these values. Don't use these values because it is y values, yi values, but I need to use these j of yj and f of xi values, and using that we have to find this. Okay, so now in which column it belongs? 0.3 column, so 0.3. And in which row it belongs? 0.7. So multiply it with 0.7. Your answer will be 0.21. Okay, you got my point? So this, so where it is present, in which column it is present, 0.3, and which row is present, 0.7. Just multiply both, you'll get it. Similarly, j12, which row, sorry, which column? It belongs to 0.5 multiplied by, in which row? 0.7, 0.35. Clear? j13, this one. Which column? 0.2. Which row? 0.7, 0.14. Clear? Similarly, j21, which column? Which column? 0.3. Which row? 0.3. 0.9. And this one J22, which row, sorry, which column? 0.5. 0.5 into which row? 0.3. 0.15. J23, this one, which column? 0.2. Which row? 0.3. That means 0.6. We shall verify it once. Okay, so 0.34, 0.9150. Okay, 0 I sorry, this is 0.06. 0.06. Okay, and also this is also 0.09. Okay. Okay, so now we have got the values. Now again we shall construct the same box. Now we shall substitute these values. Okay, nothing but x bar y bar minus 2 5 8 f of xi 0.7 0.3 1 1 2 g of yj. Okay, this is 0.3 0.5 0.2, and now we shall substitute. So j11 having 0.21 against 0.35 0.14 0.09 0.15 0.06. Okay, we shall cross verify it whether we have clearly substituted. Yes, no doubt. So now this is the box for your distribution. I mean to say distribution of x and y. Distribution of x and y. Now we have all the three boxes: distribution of x, distribution of y, they have given question itself, and we have found the distribution of x and y. We have three boxes. Now our intention is to find covariance of x and y. What the covariance of x and y is? Formula xy, e of xy minus mu x into mu y. Okay, so now we have to separately we have to find each one's values. Okay, mu x is nothing but your e of x, can be found as okay, so e of x can be found as summation I xi into f of xi. So I can find using I can find these e of x, nothing but mu x can be found by using your distribution table of x, that thing but 1 into, that is your xi into f of xi, 1 into 0.7, 1 into 0.7 plus 2 into 0.3. Yes, 2 into 0.3. So your mu x value will be 1.3. I have already solved this in my previous video, so that's why I feel you can solve it by yourself. Okay, but also I'll just provide you my answers, you just verify whether it's correct or no. So my mu y again, but similarly in a similar fashion we can also find my e of y, that is nothing but my mu y, that is equal to summation j yj into g of yj. Okay, nothing but you have to use this y distribution table. 2 minus 2 into 0.3 minus 2 into 0.3 plus 5 into 0.5 5 into 0.5 plus 8 into 0.2. Okay, your answer will be 3.5. yes, you just verify, cross verify it. And now the main part is xy. E of xy we can find nothing but summation I comma j xi into yj into jij. Nothing but we have to use this distribution of x and y. So nothing but we shall do it. Okay, so now xi, this is my xi into yi into jij. So these three values we have to multiply. That means 1 into minus 2 into 0.21 plus this value, that means the xi, first xi value into this and into this. Okay, so we have moved to second row. This is first column, second column and first row. That is first row, that is xi, first xi value into second yj value into this j12 value, that is 0.35, nothing but 1 into 5 into 0.35, again plus 1 into 8 into 0.15 1 4. Okay, plus again now we shall move to our second row. This first row has been completed. Now we shall solve second row. 2 into minus 2 into 0.09, 2 into minus 2 into 0.9 plus 2 into 5 into 0.15, 2 into 5 into 0.15 plus 2 into 8 into 0.06, 2 into 8 into 0.06. So the final answer of this will be equal to 4.55. Now all values I have found, that is mu x value, mu y value, e of x value, just you need to substitute it. 4.55, that is e of xy can have 4.55 minus mu x is nothing but 1.3 into 3.5. You just do it in your calculator. Wait, we'll solve it. 4.55 minus 1.3 into 3.5. See, the value is 0. That means we have verified that covariance of x comma y is 0. That means what they have asked, it is been clearly verified. Okay, so now I hope this example you have been understood well. Okay, so in another video we shall discuss some more types in my joint probability distribution. So till then, learn well, and if you have any doubts or queries, you can comment me below. Okay, thank you.